Hello everyone, I hope I'm audible to you guys. If yes, then please, any one of you can raise your hand and let me know. Yeah, okay, looks audible. So welcome Ashwin, welcome Kundan, welcome Gurpal, welcome Jasneet, welcome Ramesh, welcome Rancy. Welcome everyone. We will be starting shortly. Please stay tuned till then. Okay, so we got a few more people with us. Welcome Sri Lakshmi, welcome Sobia, welcome Ranmani, welcome Morufu. Yeah, so guys, should we make it a bit interactive till we guys kick off this session? If I just let you know, if any one of you uh, tuned into the session from a mobile or iPad or something, then if possible, you guys can shift it over desktop or laptop, anything, so that it would be much easier for you guys to cope up with the speaker. And till others join, let's wait for a few more people and then we'll start. I can see I got a text from one of you guys that some people are still attending the other session on neural network. So yeah, that might be a possible reason, as we got our today's speaker with us. So let's wait for a few more minutes and then we'll kick off. Hey Raghu, I'm audible. I'm audible to you.
Yes, you are.
Yeah. Welcome to the session. And would you like to like share your screen and try your setup or something if you want?
Sure, just give me a second.
Yeah.
Hey, I don't have permission to share my screen.
Yeah. Sorry, just a second. Yeah. Not right.
I would probably turn on my camera as well just to test it. 1 second. This is Mukesh, right? Hey, nice. Good. Share my screen. There you go. Yeah, works fine.
Yeah. Looks good.
This is Mukesh, right?
No. I'm Shreyas from Analytics Vidhya.
You sound very similar to Mukesh. Okay, that's fine.
Okay.
Anyway.
Okay. I really don't have any idea who Mukesh is.
No worries. I mean, Mukesh heads the data engineering division probably. So I talk to him quite often. So you really sound like him. So I was thinking like you are Mukesh. Maybe it's okay.
Okay. No worries.
Hey, you can see me as well, right? Do you want me to turn on my camera during the session, or do you want me to switch off?
It, it's totally on you. Like as you feel comfortable.
Okay,
Like neither
maybe
mandatory, no.
maybe at the beginning we'll do it, like so people can see that it's a human being, not a robot taking the session probably, and then probably
Yeah.
we'll turn it off
Absolutely.
later. Hey guys, good evening. Yet another. So I already got a lot of questions. Please start from the basics, no worries, so many things. Yeah, so
Actually, there's a session going on from 7 or 7:30
okay.
for neural section for neural networks, I guess. So
Mm-hmm.
people are attending that. That's why
Uh-huh.
we are having a quite less attendees here.
Okay, so yeah, fine, no issues. We can start whenever you are ready.
Yeah,
I
we'll start in a few minutes.
Sure, no problem.
So hello everyone. I really hope you all are doing great, and it's such a great feeling to see you guys joining us today. And welcome to all of you in another session of DataHour series. As we will be starting in a couple of minutes. Till then, we should interact a bit. As I'm launching two polls here. which is for location and experience level of you guys. So please interact in the poll till we get other people as well. And apart from that, I will be sharing links for our upcoming sessions. And this session will be available on YouTube in a few days, and even it's streaming live. So I will be providing you guys with link for the same. Everyone, please participate in the poll launched just right now, a couple of minutes ago, as we will be just starting in 2 to 5 minutes. So till then, I would love to get entries from everyone. So yeah, we are good to go. So hello and welcome everyone to another session in the DataHour series. As we are really thrilled to be here with you this evening for such an adventurous session with interactive learning. I am Shresht Sahu, part of data science team at Analytics Vidhya, and I will be the moderator for this session. And for those who have joined us for the very first time, a brief introduction about the DataHour sessions. The DataHour series is a sessions conducted by Analytics Vidhya, led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests itself, it's totally 1 hour dedicated to data. Now on to our today's session, which is analyzing movie data using MongoDB. NoSQL databases are the databases we use NoSQL databases are the databases we use for modern day applications, and they differ from RDMS platforms in many ways. As in this data hour, Raghu is going to demonstrate one of the most popular NoSQL databases, that is MongoDB. And an important note for everyone, before we kick things off and I hand it over to the speaker, a quick recap of the housekeeping items that we are recording the session and we will be making the recordings available in a few days on our YouTube channel, for which you will get the link in chat section. And secondly, please use the question and answer section for asking any doubts, any queries you might have during the session, and we will do our best to answer them as the data hour progresses towards the end. And last but not the least, we will share a feedback poll towards the end of the session, which I request you all to participate in. And now today on to today's speaker, which is Mr. Raghu Raman AV. As Raghu is currently working as consultant and freelancer trainer in the big data technologies. With over 15 years of extensive experience in the IT industry, Raghu has designed and developed large-scale enterprise applications. And apart from this, he has deep expertise in building data analytics solutions using AWS, Azure, and Google Cloud Platform. Raghu is well versed in all big data components available on these cloud providers and knows how to build solutions using it. And this really sounds inspiring and wonderful. So over to you, Raghu. The virtual stage is all yours.
Hey, thank you. Thanks a lot. So, I don't know. So welcome all of you to the Data Hour, and thank you for the wonderful and kind introduction. My name is Raghu Raman. You can just call me Raghu. So since we are already set with the basic housekeeping items and all, I would just like to add on one more thing. See, the idea behind the Data Hour sessions is to introduce new tools and technologies to people who are interested to get started with a career here, right? And these are Data Hour sessions. So that means I will be talking about something for an hour. So it's like 60 minutes. Now you take any tool or technology, it's practically impossible to cover everything in 1 hour. So just consider this like a taste of the tool. It's not going to be a complete end-to-end training or anything. So I just wanted to set the expectation right before we start. This will be just the tip of the iceberg so that you just get an idea about NoSQLs and MongoDB. A complete comprehensive course on Mongo or something will be beyond the scope of 1 hour, and we probably will not be attempting that. But having said that, I will try to cover the basics and the interesting parts of NoSQL and Mongo, whatever I can. And since it is a 1 hour session, I will complete my topics first, and then I will pick up your questions. So questions will be moderated and will be picked up by the end of the session. So after 60 minutes, we can spend around 10 minutes, 10 to 15 max on questions. I would say around 10 minutes, and see if I can answer any of them, right? So let's get started with the topic of the day. So I'm going to turn off my video to, I'm just going to turn off my video for the time being, and I'll turn it on when we are in the Q&A. And the topic that we have is something called NoSQL Databases and MongoDB. Well, I'm not really a huge fan of slides. I don't run a lot of slides and all, but just to talk a little bit about this, I will be using some slides. So the first question that people ask is, the moment I say NoSQL database, the first question that people ask me is, hey, did you just say a database? Yeah. Is that an RDBMS? I thought database means RDBMS. Well, you are correct. And, I cannot find fault in your judgment because, most of the world, they think about RDBMS platforms if I say the word database, right? So you are familiar with the relational databases like MySQLs and Oracles, ACID properties, and so on and so forth, right? So you see, in a regular project, when people think about storing data in a very structured way and then later querying the same data, they introduce something called an RDBMS. But there is another world which is totally different. That's where I come in, and it is called the big data world. So most of you might have heard about this term called big data, and even some of you might be familiar with it even. So big data stands for data sets which are so huge and complex so that traditional systems cannot handle them, right? And there is a huge list of topics in big data and tools and technologies. So we don't want to jump into that side, but in very simple ways, when somebody asks you what is big data, it is data sets which are really huge. For example, gigabytes and terabytes, even petabytes. So 1 petabyte is like 1,000 terabyte. So imagine you are having terabytes and petabytes of data. And also imagine this is a combination of structured, semi-structured, and unstructured data. That's what we call big data. So put it in very simple terms, you cannot use your RDBMS platforms in the big data world. Yeah, RDBMS exists to solve certain kind of problems in the non-big data world. Say, for example, in a bank, if you make transactions, that's probably stored and processed by an RDBMS. And I have no offense for that. An RDBMS should be there, in fact, right? But when we come to this world of big data, RDBMS systems doesn't really scale and fit in the big data world. So there are numerous reasons behind it, and you can probably understand the size itself is a big problem, right? So RDBMS is typically designed to handle small scale data. Also, it is designed to handle structured data more. So in simple terms, I can say that RDBMS may not really fit in our big data world. So that's when we talk about something called NoSQL databases. So like I said, in simple terms, NoSQL databases are databases which you can use to handle big data. Now, first question you may be thinking is like, okay, can you give me some example? Like you say big data all the time, but why do I need a NoSQL database? Let me give you a couple of examples. Well, the first thing will be Amazon. So you see, you open Amazon, and let's say you click on any product. Well, I love iPhone, so I'm going to click on iPhone. Now, all of you browse Amazon, right? But have you ever been curious about Amazon, except the pricing and offers? People are always curious about pricing and offers. Have you been really technically curious about Amazon? You see, if I click on a product in Amazon, you see immediately the page loads. Yeah, so now you can see the Apple iPhone 13 page which came within a second. Now look at the amount of information you have on this page. The price, the offers, the questions, the reviews, the photo, the video, the color, blah, 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 blah. I can go on and on and on and on. Do you really think this page is coming from an RDBMS? If you say yes, you are wrong. So I win, right? See, Amazon has millions of products, and each product has different properties. A washing machine and a refrigerator and an N95 mask, all are having different properties. Now, do you really think you can create an RDBMS table and fit all this data? And millions of people should be able to browse them as well. So this is an example where you're dealing with massive amount of data, that too in different structure, and you need a different database. Take another example. Let's say Trivago. A company like Trivago, it's a travel and tourism company, right? You can book flights and cars and holidays, whatnot. Now, let's say you want to capture this information from Trivago. You know what people are searching? Do you really think an RDBMS will fit here? Well, no, because Trivago says every second they're processing thousands of requests like that. Now, imagine in a month, they have millions and billions of records that may not fit in a RDBMS platform, right? So these are some of the examples where we think about something called NoSQL database. Now, what is this name called NoSQL? It is, some people say non-SQL and some people say not only SQL. Well, either way, I would like to call it not only SQL. So NoSQL databases are not only SQL databases where they try to solve the problems which cannot be solved by RDBMS, right? Now, what are some of the advantages of using NoSQL databases? First of all, they can store different types of data. The data can come in structured format like a CSV file. It can also come in semi-structured format like a JSON file or an XML file. It can be even completely unstructured format. So NoSQL databases doesn't really care about what kind of data you feed. Also, these are distributed databases. Now, this might feel a little bit out of the world. So distributed computing is something which is completely new for many of you, I believe. So what it basically means, when we say NoSQL databases are distributed, you can install them in a group of machines. Now, you see, RDBMS usually gets installed in a single box, a server, you can say, right? So any RDBMS system, normally you need just a single machine to install. But one of the challenge we have in the big data world is that the size of data is really huge. So what if you have 100 terabytes of data? You cannot store it in a single machine. So that's when we go for distributed computing, where we use a group of machines. So the NoSQL databases are typically distributed databases. That means NoSQL databases are installed in a cluster. A cluster means group of computers. To give you an example, MongoDB is a NoSQL database. You can take 100 machines and install MongoDB. And these 100 machines will act like a single machine. That's called distributed computing. Anyway, and what are some of the features of NoSQL databases? The first thing is flexible schema. You see, you look at this example, the product catalog of Amazon. Now, if I ask you to design a table, you will be confused because the schema will be very challenging. Like I said, a phone will have different features, washing machine will have different. So if you design an RDBMS table, you have to stick with one schema. But in NoSQL databases, you will be able to keep on adding or making changes. You have this idea of flexible schema. Okay, so what I mean by flexible schema is like in majority of NoSQL databases, you don't have to define schema upfront. Okay, the schema can evolve over the time and there is no predefined schema. In RDBMS, you always start by create table, blah, blah, blah. So you have a fixed number of column and you can expand it, but it is very difficult. But in NoSQL databases, they are designed to handle the modern day web applications and they support flexible schema. That means you don't have to define the schema in advance and they adopt to any changing requirement. What could be another example for this flexible schema? Now, remember when COVID hit us? Well, it was bad, right? So, so when COVID came, I don't know how many of you tried this. All the flights were halted, right? There were no more flights. Then what happened? I think after an year, they started flights. No, not like full-fledged, but some flights started. So I still remember those days when I tried to book a flight because I had an emergency. I had to travel during COVID. Now, if you go to Trivago in 2020, in their website, you also had to fill in some details. For example, are you coming from a containment zone, right? Did you take the RT-PCR test? Then what happened? Vaccination came. And then Trivago started asking questions like, have you taken vaccination? Yes. If yes, which vaccine did you take? So their front end changed. You see, so the back end should also be flexible, right? See, today Trivago says, I'm going to collect only your name and email. Tomorrow they say, I want your vaccination status. So accordingly, your backend database should change. So that's what we call flexible schema. That's a real world example for flexible schema. So anyway, NoSQL databases support flexible schema. They are also horizontally scalable. What I mean by this is like, they support this distributed computing. So you can start with a single machine. Say, for example, you install MongoDB. We'll come to MongoDB in a single box. And if you feel the size of data is getting bigger and bigger, you add 2 more machines. Now you have 3 machines. And still, if the size is getting bigger, you add 4 more machines. I mean, this is just an example. It does not mean like, you have to always add 2 and 4 machines, but the idea is you can scale the database horizontally. Horizontally means you can keep on adding new machines to get extra storage, extra processing, so on and so forth. So NoSQL databases can store practically unlimited data. Also, there is one more point which is not mentioned in the slide. The other drawback of RDBMS, well, I won't call it as a drawback, but another problem with RDBMS is that they are very costly. Say, for example, if you look at Oracle. Now, Oracle may have a solution where you can handle big data. Probably, I'm not sure. But the cost part will be very high because Oracle is a proprietary product and they give you licensing charge, support charge, and everything. On the other hand, most of the NoSQL databases are open source. So that means your price also drastically come down. And especially in the big data world, we have to be really bothered about the price, okay? The next advantage of using NoSQL is the ease of development, right? I will show you this. It's very easy to get started with NoSQL databases and insert your data, query your data, So NoSQL databases, they have their own language in the sense they don't support, SQL or SQL. The NoSQL databases are having their own language, right? With that, let me specifically talk about MongoDB. Okay, so one question people might have in their mind is like, how many NoSQL databases are there, and why are you specifically talking about MongoDB? Well, surprisingly, there are so many NoSQL databases in the world. There is something called Cassandra, DynamoDB, Neo4j, CouchDB, HBase, Bigtable, Voldemort, MongoDB, React, Tokyo Cabinet. The list goes on. Okay. Now, among all of them, why are we specifically talking about MongoDB? The reason is MongoDB is the most popular NoSQL database in the world. Honestly speaking, I mean, it's not something that I make up. You can actually go to DB Engine ranking website and verify this. MongoDB is the most popular NoSQL database. So it makes sense to talk about it. That does not mean others are bad. For example, Cassandra is a great NoSQL database, but we have a DataHour session, right? So I picked up MongoDB. So MongoDB is open source, okay? But there is a commercial version of MongoDB as well, right? So you can either choose the community version, which is open source in MongoDB, or the enterprise version, which is the paid one. It's a NoSQL database. It's a document-based NoSQL database. What do you mean? I will explain this. What does it mean by document-based? So MongoDB stores all your data in the form of a document. That's what I'm coming to. What are some of the features of MongoDB? It is flexible. It's document database. What I mean by document database is MongoDB internally stores the data in the form of a JSON document. What is JSON? JavaScript Standard Object Notation. JSON is a very lightweight format to store your data, where you store it in the form of a key value pair. Now, look at this particular data that you would like to store. And you can store it like this in MongoDB. So let's say you want to store some movie information. Now, there is one movie, Godfather. So you have a title, the genre, the director, year, critics rating, actors, so many things, right? Now you have another movie called Goodfellas. Okay, maybe my favorite. Martin Scorsese's movie, right? So you look at the way you are storing Goodfellas. It has title, genre, director, year. There is no critic rating and actors for Goodfellas. I don't know why, but you don't have that information. Now you can store both this data in the same table in MongoDB. MongoDB will not complain. Now, that doesn't mean for Goodfellas, critic rating and actors are null values. No, there is no null value. The schema is completely flexible. MongoDB doesn't demand any upfront schema. That means you can store whatever you want in whichever format you want, which is great. So document database basically means MongoDB internally stores your data in the form of a JSON document, right? And there is high availability in MongoDB. So normally when you create a MongoDB, cluster, what you do is you will have primary machines and secondary machines. So naturally, one of the concern will be losing your data, right? So what if some of the machine goes down? Will I lose my data? No. MongoDB has what we call a replica set. A replica set is a combination of primary and secondary machines. So what happens in this picture, like you can see, there are 3 machines, 1 primary and 2 secondary. Now, let's say you have a client which is writing the data to primary. The moment primary gets the data, it replicates that to secondaries, right? So you end up having like 3 copies of your data. So in case if your primary goes down, one of the secondary will be elected as the new primary. So that means you will get 3 copies of data, and even if 2 machines go down, still you can read your data. And in MongoDB, all the writes should go to primary. The reads can be from primary or secondary, right? So there is also horizontal scalability. We talked about it. And you have a very rich query language in MongoDB. Like you can have insert, updates, delete operations, very similar to SQL. You can have data aggregation in MongoDB. Aggregation means, like group by queries and all. Now, why this might be a feature? You may be thinking like a group by query should work everywhere. Not really. NoSQL databases, the majority of them are not designed to run aggregate queries. Okay. For example, Cassandra supports aggregation, but it takes a toll on the performance. On the other hand, MongoDB is designed to do data aggregation. So you can run aggregate queries like group bys and whatnot in MongoDB. And you also have text search. You can create indexes on text fields and you can search very fast. And you also have something called geospatial queries. Maybe one of the reason MongoDB is very popular is because of this geospatial queries. See, I'm quite sure all of you have experienced this, like you open Google and you can search for ATM near me or petrol bunk near me or whatever near me. Not only Google, a lot of apps allow you to search things around you, nearby. So how does this work? If I open Google, so this works as what we call geospatial queries. And MongoDB can do that. So MongoDB can store your data in the form of latitude and longitude, that is a location data, and your queries can be fired around locations. Those are called geospatial queries, and MongoDB supports that. And who uses MongoDB? Almost everybody. It is such a popular NoSQL database. Adobe, eBay, CERN. CERN is the European Research Agency. Have you heard about these God particles? There is a particle accelerator project. Slip my tongue, right? So CERN is the European Research Agency. AstraZeneca is the pharmaceutical company who created the COVID vaccine, right? Then Bosch, Barclays, Thermo Fisher, the list is endless. MongoDB is pretty popular. Now, once we understand this last slide, maybe I will try to show you something in MongoDB. So when you compare RDBMS and MongoDB, in RDBMS, you start with a database. Like you will say, create database, blah, blah, blah. In MongoDB also, you start with a database. And in RDBMS, inside a database, you have tables. MongoDB doesn't have tables. It has collections. Collections are like tables. Well, not same. Like collections are containers. You can think about them similar to tables if you want to understand. And in RDBMS, inside a table, you have rows of data. You insert the data row by row. But in MongoDB, inside a collection, you have JSON documents, right? So basically, you are having JSON documents. So what I mean to say here is in MongoDB, you first create a database. Inside that, you create a collection. Inside that, you can store your JSON document. That's the structure in MongoDB. Okay, enough of theory. We'll try to do something. Interestingly, I love surprises. I don't know whether you love surprises. I love surprises. So today's topic was analyzing movie data using MongoDB. And we are not going to do that. That's a surprise. Well, we can analyze movie data, but the movie data seems to be like boring. Everybody talks about movie data. So I thought I'll do something else. So instead of analyzing movie data, we will be analyzing Airbnb data. That will be more interesting. So this is the official MongoDB website. And as you can see in the products, there is something called Atlas. Now, Atlas is nothing but MongoDB in the cloud. Then there is Enterprise Advanced, which is the paid edition of MongoDB. And then there is Community Edition. Community Edition is the free open source edition of MongoDB. I have already installed MongoDB Community Edition on my laptop. And how do you work with MongoDB? So there are several ways to work with MongoDB. MongoDB provides an interactive shell and a client to work with it. So I can just type Mongo. So the MongoDB server is already running on my laptop, and Mongo is the client. So if I just type Mongo, hit enter, you can see here MongoDB shell version 4. It says connecting to MongoDB. This is localhost 27017 is the default port number in which MongoDB server will be running. So we just connected to MongoDB server, and this is the prompt. So you can type your MongoDB commands here. Now we will load an actual data, but before that, something that I want to show you. In MongoDB, there is no create database command. So usually, the first thing that you do in any database is you say create database name. And here, we don't have that. Here, you can just say use. If you say use and any database name, it will automatically create the database and switch to that database. So let's say use, this is August_AV. So as you can see, when I say use, it tells me switch to DB August AV, right? So there is no need to type create database. And now we need to create a collection, db.create collection. Let's call it as orders. So the command to create a collection is db dot, and db refers to the current database, create collection. And the name of the collection is orders. A collection is like a table. So if I say show collections, you can see there is a collection called orders. And MongoDB doesn't demand any schema for this collection. So we just created a collection called orders. Good. And let's try to insert something so I can show you something. So this is the command to insert data in MongoDB. Sorry. So db.orders.insert1. Well, you can insert many documents at a time, but right now I'm inserting one. So DB refers to the current database. Orders is the collection. I'm inserting this particular JSON document. You can see this is in the proper JSON format where order ID is the key, one is the value. Order date is the key, This is the value. Then you have order customer ID and order status. MongoDB says acknowledge true. So it got the data. Now let's insert one more document. So I inserted one more document where the order ID is 2, order date, customer ID, status. What is interesting here, in my second document, I have an extra key value pair. But MongoDB doesn't complain. It is not going to tell me like, hey, in the previous JSON, this key is not there. So this is what I mean by flexible schema. You can insert whatever you want. The only condition, it has to be a JSON, right? Now, how do you see the data that you have inserted? db.orders.find. So find is the query operator. Any MongoDB query will have a find. So right now, when I say db.orders.find, it is more or less like select star from the table. And you can see that this is the first document we inserted. This is the second document we inserted. MongoDB adds an additional key value pair called _ID. Now, this is internally added by MongoDB. For every document, it will add this unique _ID field. Okay. Now, when you query the data, like if you just say find, you are able to see the data. And we will now look at another data set. Okay, so this is the Airbnb data we have. So I have a CSV file, and so this CSV file shows about the Airbnb listings of Madrid, Spain. You know Airbnb, right? So it has so many columns. There is the ID. This is the listing URL. If you go to this URL, you can actually see the listing. I don't know if it is removed, but if I copy this and go here, there you go. So this is the room, Airbnb, rooftop, terrace room, blah, 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 right? So you have the listing URL. What happened? Okay, let me scroll up. Sorry, guys, just relaunch it. Come on. Yeah. So there is an ID. There is a listing URL. Not all columns are interested for us. Then there is a name of the property. There is a description. There is a neighborhood. There is a picture for the property. Host ID. If you're the Airbnb host, host URL, host name, host location. So you can see there are so many columns in this. Okay. Then the host ratings and reviews and how many bedrooms, bathrooms, neighborhoods, so many columns are there. See this? So what I want to do, I want to load this data to MongoDB. Now, there are many ways to load the data, but the easiest one I find is using this tool called MongoDB Compass. So there is a tool called MongoDB Compass. Compass is a GUI, graphical user interface for MongoDB. I can just connect with my MongoDB. And let me just delete this so I can create it. Yeah. Now I can create a database here. I'm just going to say create database. So instead of using the command line, I can use Compass. It is one and the same. Either you go to the command line and type use DB, or you use Compass to create a database. So let's create a database called DataHour. And let's also have a collection. You open this. I think it is called listings. Okay. So I'm going to create a collection called listings, create database. So you can see there is a DB called DataHour, and there is a collection called listings. Now I can insert the data manually, but you can also upload the data. So you can go to this add data. There is an import file option. Select the file, and we have the Airbnb listings open. And when you open the files, MongoDB will identify it's a CSV file. So it's going to pick up the column name as the key and the value as value. And it will ask you to select the data type as well. For example, ID is integer. These are string columns, I know. Now, let me just check if I have to change any data type, okay? So it gives you this sample data, which is nice, I believe. Or string, no worries. URL is string. Host ID should be integer, I believe. Then you have a lot of string values again, you know, a lot of them. These are like true, false. Again, I can just, let me just, so this should be integer. Sorry, this should be string. This should be integer. This should be again integer. These are numbers, you know. And this should be integer. This should be again integer. And I'm just setting some of the, you know, columns to the data type, correct data type. I mean, it is again string. You see, it's very big actually. Price, minimum nights. We can actually change all of them, but I'm not going to change that because we don't need all these columns for our small case study. Number of reviews should be integer. This also should be integer. Review rating should be double. Sorry. Review score should also be double. Yeah. I think we are good right now. Yeah. And you can just say import. So you can see that around 164,000 JSON documents are created. Interesting, huh? And you can see the data. Done. See the data. See, it's all key value pair. Listing URL, ID, name, description, picture, host ID, you know. So this is how your data looks in MongoDB now. So there are a lot of key value pairs, okay? And let's now access this using our shell. So I can say use DataHour. And if I say show collections, now I cannot just do a blind find query here. Because if I say just find, there are like 160,000 documents, all will be shown. That will be terrible. So there is another thing that you can do. If you want to see how the data looks like, you just do a db dot listings dot find one. There is a query called find one. It basically means, hey, MongoDB, show me the first document in a nice format. Okay. In fact, you can say find and dot limit one. So if I do this, this is equal to select star limit one. But if I do this, are you able to understand anything? No, I'm not able to understand anything. It's all a mess. Instead of this, you do a find one. See the difference. When you do a find one, it will be properly formatted. See this? Very nice, huh? So you can see when I did a find one, it is showing me the first document. So there is like ID, URL, name, description. See the description? Very nice, huh? picture URL, host ID, host name, all these things you can see, proper format you can see, which is nice. Right now, let's try to pick up some basic queries in MongoDB so we can run them probably. Right. So what I want to do is choose two hosts by referring to their host ID who are super hosts and show all of their listing offered by both of them. So I want to find a super host first. Let me show you how we can do that. So this is the way you typically write a MongoDB query. So you start by the find, because any MongoDB query will start with a find. And there is a key called host is superhost. I can show you this. See this? Can you see what I'm highlighting? Host is superhost. It's a true or false. It is false for this guy. Okay. So I can give a condition here. Host is superhost, true. So this is how you give conditions in MongoDB, like a filter, you can say, right? Now, this will give you all the documents where there is a superhost. Then what you do is, these are the projections. So basically what I'm trying to do here is that I'm saying that show me all the documents where the host is a superhost and only show me their host ID and host name. So you can see we are getting the host ID and host name. So these are all our superhost. So the first part of the query is like a selection criteria. Like, what is your condition? An equivalent SQL query will be select host ID, host name from the table where host is superhost equal to true. So in SQL also you have this projection, right? Like, you don't say select star, you say select certain column. That projection or selecting certain columns is happening here. Wherever you put a 1, MongoDB will show that column. So here you can see host ID 1, host name 1. It means show me the host ID and host name of all the hosts who is superhost. Now there are many of them. You can see here, type it for more. It is iterator. So basically it shows you like 20 hosts. If I type it, again another 20 will come. It, another 20 will come. It, another 20 will come. It's like an iterator, you get a cursor and you can iterate. So I first get a list of superhost, and from that I'm picking 2 hosts. Okay. So I'm creating a variable here. Let is a command that's like you declare a variable in MongoDB. 3 criteria is the name of my variable. And in my variable, I'm checking whether it is host ID 13660 or 4286142. So this is like a OR condition in MongoDB. Okay. So I'm just checking, okay, is my host this or this? So if you find any of these hosts, what you should do? I want to do a projection now. Copy this. So I create another variable called 3 projection, where I say that I want to see the name of the host, price, neighborhood, host name, and host is superhost. Finally, I include this in my query. Sorry. So what you see here is, if I go up, let me explain this query once more. So the actual query is running here. You can see that I'm doing a db.listings.find remember, all MongoDB queries will have a find. So the actual query is here, but this time you are passing two variables inside the query. The first variable is 3 criteria. Next variable is 3 projection. What is inside 3 criteria? You are putting an OR condition. You are trying to match either this host, Simon, or this host, Ricardo. What is there in the second variable? The projection. I want to see the name, price, neighborhood, host name, and all. Now, when you run this query, okay, you can see that for Simon, there is a property called rooftop terrace room. For Ricardo, there is Madrid sender, something is there. Again, for Ricardo, there is an amazing loft. Ricardo, Opsum, something is there. So you can see the listings by the superhost. So as you can see, the MongoDB queries are not like your SQL queries. Okay, it's not like your SQL queries. The language is different, and so the queries are slightly different. Now, if you want to find a distinct host name, this might be the query. So what did I type? db dot, which refers to the current database, listings dot, that represents the collection, distinct host name. So there is a key called host name. So you will be getting the unique host names in this list, right? Probably let's run one more query, right? And then I'll pick up your questions probably, right? So this is what we want to do. Find all of the places that have more than 2 beds in the neighborhood of your choice, referred to as neighborhood group cleansed in the data file, ordered by review score rating descending. So what we are trying to do first is we are creating again a variable, as you can see. So the name of the variable is 5 criteria, where we are taking a neighborhood called Centro and number of beds greater than 2. So I'm concentrating on this neighborhood called Centro. So 2 conditions are there. First condition, the neighborhood must be Centro. Number of bedrooms should be greater than 2. $GT is an operator in MongoDB where it is greater than. Okay. And now let's do the projection. Projection means what columns you should see in the output. So there is a variable called 5 projection. I want to see the name of the listing, number of bedroom, review score rating, and price. Finally, let's run the query. There you go. So what is the query? db.listings.find, and I pass my criteria first. What is the criteria? Neighborhood is Centro, number of bedrooms should be more than 2. Then I pass my projection. And once I get the result, there is a sort operator in MongoDB. So I call the sort operator on the final output, where I try to sort the data based on review scores rating in the ascending order. So you can see there is this particular listing, number of bedroom 3, this is the price. Then there is this again, number of bedroom 3, and this is the price. So you can see they are sorted also in the order as we can see, which is quite interesting, right? So I know that probably it's just a very brief introduction to MongoDB, but we also should consider the time that we have in hand. So talking about MongoDB, a complete overview of MongoDB, if you need to get it, then ideally a comprehensive course on MongoDB should be taken. but at the same time, I can also help you a little bit. So you can just go to Google and search for MongoDB University. So there is something called MongoDB University, where this is created by the MongoDB team, where they offer free courses on MongoDB. So check out this site, and these are all pre-recorded content, like videos will be pre-recorded, but this will help you to get started with MongoDB. At least get your hands dirty with this, right? So now what I will do, I'll pick up some questions, see if I can answer some of them. We might have around 10 minutes. 2 queries for use case such as varying column attributes, say for prospective or diagnostic leading to wide columns and need for flexible. Is NoSQL right solution? Absolutely. So Venkat, NoSQL is the right solution. First question, are CRM built on NoSQL? Can be, cannot be. So it's not like mandatory. CRMs can use NoSQL in the backend, but of course, they can be built on what you call NoSQL or SQL. Yeah. What can go wrong with NoSQL database? Oh, that's a good question. So with NoSQL database, certain things might go wrong in the sense like they are open source. So they don't offer the rigid stability as RDBMS at times. Okay, that's one small problem with them. You cannot have transactions in NoSQL. You can have only operations. Like they don't support the ACID properties and all. And also learning them might be challenging because each will have a different language. So if you learn MongoDB, then you cannot work on Cassandra because Cassandra has a different language. So this can be a little bit challenging. Kiran, MongoDB has an open source version as well as a commercial version. Both are there for MongoDB. Yeah. There are many ways of working with MongoDB. Which one is best? No, there is no best actually, Ashwin. So you can use the shell, like I told you right now. You can also use Compass, which is a GUI. Both these are given with MongoDB. Like if you download MongoDB, you will get the shell. You will also get the what you call Compass. But there are so many third-party tools. There is something called RoboMongo. There is something called NoSQL Booster for MongoDB. So a lot of third-party tools are also there to work with MongoDB. RoboMongo seems to be the most popular tool, RoboMongo. Okay. Done. You touched upon a number of advantages. Are there any challenges? I think I answered that a little bit. What is MongoDB Playground? MongoDB Playground, I believe it is a place where you can set up an environment and test your code, right? So Playground is like, you can try things out, So it's an environment where you can set up your code and test it and play around with it. Yeah, Felix, it'll be recorded. Yash will try to do that, right? With over 80% of all data represented by unstructured data today, why are NoSQL not overwhelmingly in use? No, you are mistaken. NoSQL databases are overwhelmingly in use, honestly speaking. Okay. It's just that in the traditional world, you don't see them. Like if you are working with regular data, you don't see NoSQLs, right? They are overwhelmingly in use, honestly speaking. So Ashwin of my team will get back to you on the sample data set. Even for installation of MongoDB, we'll talk about it. Int32 means 32-bit integer, Mehdi, right? So it supports 32-bit size integer. That's int32. If we have multiple instances of MongoDB, when we retrieve data, how to know from which instance to retrieve the data? Okay, So Roya, that has to do with the architecture. You don't have to worry. So when you insert the data, it actually go to, let's say, a particular machine. And there is something called MongoDB router process. So when you write a query, your query will hit the MongoDB router, and that will have a configuration file which will locate your data. So the MongoDB router will tell you that, okay, your query requires this data that is available in machine number 3. So you will be routed there. Okay. Is Postgres NoSQL database? No, it's an RDBMS actually. Sir, is the language differ for every NoSQL? Absolutely. Tago, right? So like I said, Cassandra speaks a different language. MongoDB speaks a different language. DynamoDB speaks a different language, right? Yeah, so maybe I missed that part, Shresha. Pretty actually formats the output in a proper JSON way so we can read it. So that's what Pretty does. What is the metrics of RESTful API to retrieve the data? So there are many such metrics, Roya, maybe beyond the scope of explanation right now. We will try to send you something to read about that, okay? When we say MongoDB is distributed, does it mean that we are splitting big data and storing in multiple machines? Absolutely. So there is a process called sharding, Subramanian, okay? Sharding is a process of dividing your data so it can be stored on multiple machines. So MongoDB will automatically shard your data, split it and store it in multiple machines. Huh? I am new to data analytics. What database is advisable? No, see, you have to learn an RDBMS, also a NoSQL. If you're very new to data analytics, that means you should have an experience in both sides, RDBMS as well as NoSQL. In RDBMS, anything will do. NoSQL, I will recommend MongoDB. Does AWS GCP provide service for hosting NoSQL? In that case, how do we interact with NoSQL database? Yeah, they provide service to host. They also have their own NoSQLs, Subramanian. For example, Amazon Web Service has its own NoSQL that's called DynamoDB. Google Cloud has Bigtable, that's a NoSQL. So they have their own NoSQL, or you can create a cluster and you can install them manually. That's also possible. How we are storing images and videos here. Hey, you don't store images and videos like this, Ramesh. Okay, see what happens. Your image and video may be somewhere. You will only have a URL for that. I don't know if you're able to understand what I'm saying. So you will have a key called image1. The value will be a URL. So your image may be somewhere in the cloud, but there'll be a URL for the value like that, right? How can we use MongoDB in multiple systems? Can you elaborate? Jenna, I will get back to your question later. The MongoDB connectors connect to Excel sheets, sir. Yes, you need to install a separate connector to read data from Excel, but you can do that. Commands we will see. Which one do you suggest to learn for a beginner, MongoDB or Cassandra? See, both are very similar. Okay, so there is no particular advantage for MongoDB in learning. Okay, it is just that MongoDB is popular. For a beginner, both are same. Yeah, MongoDB University has some interesting courses, right? No, Harshad, there is no joins in NoSQL world. Okay, you don't have normalization and joins in NoSQL world, but the same concept can be implemented in a different way. For example, in MongoDB, we use a technique called embedded documents to do something like join, okay? I think, how can we store the field of a resume in a JSON for posting projects? For a resume, what you can do is your name can be a key, again, value can be something. Then your company name can be the key, again, the value can be something. Also, your experience can be the key, the value can be, whatever text that you're typing. So like that, you will be able to store. No. So Venkat, NoSQL cannot replace SQL. So because NoSQL doesn't support ACID properties and also SQL will remain there. Okay. I think join I have already answered. So Uma, we can definitely do sentiment analysis and all for sure. Okay. Yeah, so pretty command people were asking. The code will look into that. Is structure of querying in MongoDB anyway similar to Pandas data frame in Python? Unfortunately, no. MongoDB has its own language, not similar to Pandas. Okay. So Shankar, I'm not sure about MongoDB University because I took a course from MongoDB University, I think 6 years back. That time there was no certification. Check out the website to see if they do provide any certification now. Okay. So guys, I think that's it with the questions for the time being. Also, we have spent around 10, 12 minutes on questions. I thank you. I thank all of you for being part of this and then interacting with me. I know that it was a very short session, and for something like MongoDB, we could have spent some more time. But the idea behind DataHour, like I said, is to show you the tip of the iceberg, right? So better luck in the future, and I wish the very best to all of you. Let's wind up this session now, and thank you for your time, folks. Thanks a lot.
Yeah, really thanks a lot, Raghu. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session. And I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. So guys, as we just wrapped up, I would like to launch a poll, which is regarding the feedback of this session. And do participate and engage in the poll to let us know about how you felt for this seminar or webinar. Meanwhile, I will be sharing LinkedIn profile of Raghu. You guys can connect over LinkedIn with him. Just a second. You guys can have link for Raghu's LinkedIn in the chat section, and I will be sharing links for YouTube channels as well, where you can find the recording of this particular session. And guys, please find the link for upcoming sessions in the chat section itself, and you can register for them as well. I'm just posting those in the chat section itself in just a second. I hope you guys have took the links from the chat section, and hence I would like to wrap up this session. And we will be back with another session of the Data Hour on 19th August, which is tomorrow. And the link for those are available in the chat section. And till then, bye-bye, keep learning.